Okay, now let's go ahead and take a look at the density lab that you have. Hopefully you've printed out your density lab. You're definitely going to need your matte pencils with you as well. Okay. There's one section or part in the density lab that I forgot to go and get, so I will record that video and put that up later, probably on Monday night. Okay. But let's go ahead and start off with this, and we can get through most of this lab already. First thing is, you definitely need to go to this website over here. It's called, we call this FET website. You might have to make sure, check your settings on your computer. I had to do that and allow it to play, was it Adobe Flash? So I had to give that permission on my computer to do that. You might have to double check, okay? If you're still having problems, you might have to go to the computer lab over at COM and work this and do this section over there with them on their computers. Once you go to this over here, then you are looking at your computer and it looks like this. That's what the website looks like. The paper kind of tells you a little bit about density. Let's go back to it. They would like you to find the mass and the volume, or sorry, define the mass and define the volume. And then they give you a little bit of information of what you're about to do. It says here at the top right of your computer screen, you're going to select where it says same mass, and it's going to be a box that looks like this. Okay, so you're going to click the one that says same mass. Fill in the table below. The blue box, which for me is kind of grayed in, is already done for you. To find the volume of an object, test how much water it displaces. Move the block and hold it under the water. How much does the water volume increase by? Because that's going to be what we call water displacement. Kind of like, imagine if you got a bathtub and you filled it all the way to the rim and the top of the water. If you were to get into it, it would displace water and water will spill out. Now let's just say you filled up that bathtub halfway. If you were to get into that bathtub, the water level will still go up. The amount of water level that it goes up is what we call water displacement. And when it comes to water displacement, that is equivalent to the volume of that object. And normally we do water displacement for irregular shaped objects. Okay? So let's go ahead and practice and let's get to this so that way we can do another one. Let's do the yellow box. But first it says that we need to click on, what was it again? Same mass. So let me come over here to my computer screen. I'm going to click same mass. And when I click same mass, here comes the boxes. Now they already did the blue box for us. So I'm going to go to the next one. It says yellow. It's 5 kilograms. And my starting level of water, you can see that little red arrow, is 100 liters. So let's get this yellow one and we put it in there. Now it's floating. We do not know the water displacement until it's shoved under the water. If it floats, then that means that you must hold it under. And once I hold it under, you can see that the water level went up to 110 liters. Okay, I let go, it floats back up again. So let me go ahead and do that. I'm going to grab a pen. I'm going to come over here. The yellow box was 5 kilograms. The volume, original volume and the displacement volume. When I held it under the water, it was 110 liters minus the original 100 liters equals 10 liters. Now the density, don't forget, they told you right here, density is mass divided by volume. So they got this mass number and they divided it by the volume, and they got the density of 1. So let me go ahead and just show you what they did. They did 5 kilograms divided by 5 liters equals 5 divided by 5 is 1. Now look at this. Kilograms and liters, like algebra class, you cannot cancel them out, so you keep both of those units. Same thing over here, what you're going to do, you're going to get 5 divided by 10 equals your answer, and your units cannot cancel each other out, so you're going to have the same units to go behind it. In science class, make sure that you always add units behind a number. Okay? That number has no meaning until you add a unit behind it. Okay? You're going to go ahead and continue this with the green box and the red box, and you can see there they are on the computer screen. And then you have a couple of questions. Question right here, and then another question, and then it says, now at the top of that little box, go ahead and click same volume. So I'm going to come back over here to my computer screen. I'm going to click same volume. And the boxes are still the same colors, but they changed a little bit. Now I'm going to go ahead and fill, it says fill in the table below, starting with the blue box. What is the mass of the blue box? 6 kilograms. So I'm going to come over here and I'm going to write 6 kilograms. Volume. It says here, should all be the same on this setting, right? If we set it to the same volume. So let's go ahead and double check. Blue box. If my volume is 100 liters, if I get it and place it in here, it sinks. Now, if it sinks, that means I don't have to hold it under the water. If it floats, I have to shove it and hold it under. So let's look at the new number, 105. So 105 liters minus 100 liters equals 5 liters. Density is mass divided by volume, or 6 kilograms divided by 5 liters. Those units do not cancel out, so get your answer and then go ahead and give me the units with it. Do the same for the other boxes. You have 2 more questions. Now go ahead and go back to the top right corner and click same density and go ahead and fill in the chart, and you have another question here. Okay, let's go ahead and turn the page, and now you're going to click where it says mystery. Okay, go ahead and click mystery. Fill in the box. Remember, if it does not sink, then you need to grab it and hold it under the water. How do I find the volume? By what we call water displacement. You get the new number, subtract the original number, and that math that you do, that's going to be the volume of that object. Find the density, which is mass divided by volume, and then it has a little question here. A couple of questions down here. And then this one here, I like this one. Hot air rises and cold air sinks. We probably all know that. We've heard that before. Now, use your understanding of density to explain the following sentences, and explain the following in sentences as if you would to explain to a younger student. So imagine there's like, a 5 or 6 year old. How would you explain it in simple terms to them? Okay? Turn the page. That was part 1 of your lab. This is part 2. Part 2 of your lab, it says here that each student, well now because we can't be in lab together, I'm going to do it. It says you're going to grab a container, which I have my container here, 3 wooden balls in it. So let me go ahead and put my 1, 2, 3 wooden balls. Then it says, go ahead and layer it with green/yellow balls, a little bit more than halfway, and then place the metal balls on top of it and close the lid. Okay, so here's my green. I've got green ones, green BBs, and then I've got metal BBs, and that's what they are. Okay, I'm going to place those in there and I'm going to layer them. The wooden balls, the green, and then the metal ones. It says here, now draw, and you must color. That's the reason for those matte pencils. So you're going to need to get a green, a brown, and black matte pencil out. Go ahead and do that drawing, and I'm expecting you all to watch this video so you can do your lab. Let's go ahead and do a little thing right here, and let's do a little container. Draw in your container, and go ahead and write starting or start, because this is going to be our original starting. Alrighty, let's go ahead and do that first and layer them in so that way you can color it. I'm going to need to set this down for a second. So let me go ahead and put this on my little holder here. That way it can be to be held up while I get this done. Alrighty, there. Now my hands are free. Alright, here's my container. I'm going to add the green BBs first because that's how it said we're going to layer them. And if we were in class, you would be doing your own, but we're not, unfortunately. There they are. The brown ones at the bottom, then the green ones. And then go ahead and layer the metal BBs on the top. Alright, so here's a top view. You can barely see the green, right? Barely see the green. And it says close the lid. So go ahead and do your first part over here where it says to color it. Use your matte pencils. Draw the little brown balls, the green ones, and then the BBs at the top, right? So we're starting off with, and here it is. There they are, 1, 2, 3. 1. And actually, the little brown wooden balls are bigger than the BBs. 2, 3. And then you're going to go ahead and color in, it's green next. And you're going to color in the green BBs. And you're going to do all of that. And then you're going to grab the black matte pencil, and then you're going to do, you should finish up to about halfway with the green, and then you're going to do the black BBs on top, right? And here it is one more time so you can see it. There's the wooden ones, there's all those green ones, and then there's like a layer of black ones. Okay, I'm trying not to, I don't want to shake them too much or move them. Oops, I messed it up. There we go. So you go ahead and finish your coloring here. Now let me go ahead and read the directions, see where we're at. It says go ahead and shake the container 4 times. Now draw, and you must color the layering of the different balls in the container at this time. Shaking the container 4 more times. Now draw it again. And then do it again 4 more times. So we're going to do it 1, 2, 3, 4 times, and we're going to shake it 4 times. And I'm going to shake it 1, 2, 3, 4. Okay? And each time you're going to color what it looks like. If you need to, then pause the video. But I'm going to go ahead and hold the camera up because it's a lot better easier to see it this view. There you go. Look, now you can see the view here. There it is. Okay, so here we go. 1, 2, 3, 4. And let me go ahead and turn this around. Oh, look at those. Look at those little brown wooden balls. It's almost like they're like stairs. 1, 2, 3. They're going up a little. Look at those. Oh, look at how they're all kind of clumped together, but look where they're at. Okay, so that's this one over here. I'm going to put this down, come back to the paper. That's this one. So you should be filling in this one right now. All right, this one. Okay, if you need to, go ahead and pause so you can fill this one in. And I'm going to go ahead and unpause it when you're ready, but I'm going to go ahead and shake it for the next time. 4 more shakes. 1, 2, 3, 4. Now look at all of that. Why don't you look right here? Do you see, I see like 1 or 2 little ones, BBs right here at the top, but the rest of them, look at how them, and look at the wooden balls. Now one is kind of missing. It's not at the bottom. He's somewhere in the middle, and look at those 2. That's pretty nifty. So now I'm going to come back to our lab paper. You should be filling in this one. Color it in on what you see. I'm going to go ahead, if you need to, pause it. Let's go to the next one and unpause it when you're ready. Let me shake it 4 more times. 1, 2, 3, 4. Let me kind of straighten it out for you. Here we go. I don't see any of the black BBs at all. Oh my, look at this. A wooden ball here and a wooden ball there. And there are absolutely no black BBs at all at the top. And look at this. Can you see that? There are some black BBs at the bottom, but no wooden balls at the bottom. That is going to be the third shake over here. Okay, if you need to, go ahead and pause it so that way you can fill it in. You just saw what it looked like. And I'm going to go ahead, when you're ready, unpause it. But let me go ahead and do the last one. 4 more shakes. 1, 2, 3, 4. Don't color it just yet. 1. You know, in science class, it doesn't always work out how you want it to. So I'm just doing a little bit more than 4 shakes because this is what I want. Now, this is what we're going to consider to be our last one. Okay? 2 of the brown wooden balls are at the top. This third one is almost to the top. Let's take a look on how the black metal balls, majority of them are at the bottom or halfway. They're moving their way to the bottom. And look at the bottom of this. Almost all of them are black metal balls versus the green ones. Okay, this is going to be your 4th one. So now, go ahead and do that container right there. Okay, if you need to, pause it and then unpause when you're ready. But I'm going to make sure that we know that we need to go ahead and explain what happened with the different balls each time you shook the container. Tell me why this happened. So why did the brown balls go to the top and the metal ones went to the bottom? Sorry, I'm trying to set the camera. Okay, so that's what you're going to answer here. Why did this happen? Let me move that out the way. I'm going to turn the page, and now we're going to hit part 3. Okay? On part 3, it says here, show your work as you determine the densities for 6 different liquids in the problems below. So 1, 2, 3, 4, 5, 6 different problems. Write your final answer in for each liquid in the small rectangles boxes. All right, let me go ahead and practice one with you. For an example, I've got mass. How do I know it's mass? Because of grams. 27.4 grams of corn syrup, which has a volume of 20 milliliters. This is V for volume. We're looking for the density, it says. So density equals mass over volume, or the mass of 27.4 grams over 20 milliliters. Again, let's don't forget, those SI units, just like algebra class, cannot cancel each other out, right? So we're going to have to keep those units as is. So 27.4 divided by 20 equals 1.37 grams per milliliter. And I'm going to go ahead and write it in the box. 1.37 grams per milliliter. Okay. Not a problem. Now you're going to go ahead and finish this for the rest of them. Okay. Then you're going to turn the page once you finish this, because you have to do this part before you get to the next part. We're still on part 3 though. Okay. We're going to go here. It tells you we're still on part 3. You're going to go ahead and fill in this box. Now, for you to fill in this box, complete the data chart or data table below by sequencing the 6 liquids by their densities. Which one? The most dense is going to be at the bottom, and the least dense is going to be at the top. Place the liquids with the lowest density at the top and the highest density at the bottom. Include the volume for each liquid as stated in the original 6 problems. Where are the original 6 problems? From the previous page. Use, it says here, the color key to go ahead and fill in the last column of the table. Okay, so trying to look for something. You're going to go ahead and you're going to fill this in. How do you know what you're going to fill in? Well, once you do those problems on the previous page, then you're going to have the densities for all of them. Where are the densities located? They're located in that little rectangular box that you have, right? Over here. You're going to find the number that is the biggest, and then you're going to go ahead and write that number here. You're going to write the name. Here are the names: corn syrup, vegetable oil, glycerin, rubbing alcohol, dishwashing liquid, and water. Those names are going to go here. The volume. Where are the volume? Here are the volumes: 20, 15, 12.6, 20, 15. I'm so sorry. That's a mass. 10 mLs. And then 20 mLs. Those are the volumes for those liquids. You're going to fill them in here. And color key, you're going to go ahead and fill in the color over here. Okay? Either write the word or else go ahead and color it in the box. One of the two. Okay? Now, after you fill in this data chart, you're going to go ahead and you're going to fill in this next part, or let's read down here. It says that you're going to pretend as if you're going to pour those 6 liquids into a graduated cylinder. Okay? When you pour those 6 liquids into a graduated cylinder, on the next page, arrange the liquids in the correct sequence based upon their densities. The most dense is going to be at the bottom, and the least dense is going to be at the top of the graduated cylinder. Okay? Be sure to follow the correct volumes when you pour or place the liquids into there. So for an example, because you should end up with 100 mLs. When you add all those up from this column, it should be 100 mLs. Here's the next page. I'm going to pretend. Let's pretend that the first one, or the most dense, is a volume of 20 milliliters. Let's pretend. That means you're going to color up to the 20 milliliter line over here, whatever color it is. Blue, white, green, yellow, red, or brown. Okay? Then you're going to come over here and you're going to start at the 20. And let's pretend that the next one is 15. Then you're going to go from 20 to 30, which is 10, and 30 to 35, which is 15. And you're going to color that in. And you're going to stack them all the way to the top, and you should reach 100. You have 2 questions to answer. Okay? Let's keep going. Part 4. Part 4 is the part that I forgot. I forgot that I needed pancake syrup. I have water. But I'm going to go ahead and color it red with red food coloring, and then rubbing alcohol. I forgot. I need to go buy some more. So I brought home a scale in a graduated cylinder. What we normally do is we get in groups and we do part of it. And the students go ahead and place their data on the board so everybody can get the data, because we don't have time to do the whole thing in lab. But I'll go ahead and do that part of it, and then you can get that from there. Okay, I will show you on the video, and you can see the scale of what the mass is and what the volume is and stuff. Okay, so as of right now, let me explain it. I'm just not going to be able to do it at this moment. Today is Sunday. I will make sure that I go buy the materials tomorrow and start working on this tomorrow. I'll video the lab then. I'm going to get pancake syrup, and I'm going to put 10 milliliters into a graduated cylinder. We're going to find the mass on a scale of just 10 milliliters. We're going to do it again, and I'm going to go ahead and pour 10 more to make it 20, and then 40, 60, 80, 100, and you're going to see what the scale says on the mass. I'm going to do that for water, and I'm going to do it for rubbing alcohol. After I do that, you're going to have the volume and the mass. With those two values, what could you find? The density. And it says here, now you need to find the densities of all the liquids for each of the volumes and then graph the data on the graphing paper provided. You must show all your work over here, your math. Your graph must be a mass per volume relationship graph. So in this case, your mass, which is in grams, will go on the y-axis, and your volume, which is milliliters, will go on the x-axis. It also says make sure to label the x and y-axis, mark the appropriate intervals on those axes, right? Whether you're going to go by tens or fives or whatever, and give the graph a title. When you graph all three liquids, make sure that you put them all on the same graph, but they're going to be in different colors. Again, matte pencils, syrup is brown, water is going to be in red, and the rubbing alcohol is going to be in green. Okay, so once you get this data over here, you're going to come this way and you're going to see what is the syrup volume. Well, we're going to do a 10 mLs. We're going to do a 20 mLs. We're going to do a 40 mLs. Where did I get this information? From the chart above. Now, what's the mass? I'm going to do that and video it tomorrow, okay, on the scale that I brought home, an electric scale, so that way you can see that, and you're going to write that here in grams. Then you're going to show your work, and what is the syrup density? You're going to get the mass, which is the number we just don't know yet, over the volume, 10 mLs, equals your density, which is grams per milliliters. Right? Please don't forget your units. They don't cancel out. You're going to do it again over here for water. Right? We're going to get the volume of the water, which we're starting off with 10 mLs, 20 mLs, 40 mLs, and then you're going to go ahead and get the mass here in grams, grams, grams. You're going to find the density by doing the math. Density is mass over volume, or we don't know the mass yet, over 10 mLs equals your answer in grams per milliliters, right? Those, again, those units do not cancel out. And you're going to keep on doing it all the way down. Then you're going to come over here and you're going to get the rubbing alcohol. Again, it's going to be 10 mLs, 20 mLs, 40 mLs, and the mass we don't know yet. It's going to be in grams. You're going to show the the density by doing the math, which is mass over volume equals, those units cannot cancel out, grams per milliliters. Remember in the notes what we said? This SI unit here, milliliters, indicates that that's a liquid, and rubbing alcohol is a liquid. Look over here. Water is a liquid. Look at this one. Pancake syrup is a liquid. Okay? You're going to do that, and then from here you're going to go ahead and you're going to use the volume and the mass numbers to do your graph. It's going to be in brown for your line. The volume and the mass to do your graph, it's going to be red. And then the volume and the mass on your graph, and it's going to be in green. You are not going to graph the densities. You're going to graph the volume and the mass. And I also have questions here for you to answer. And here is the graphing paper. It's very light, kind of hard to see, but it's there. Then on part 5, you've got questions to answer. Okay, 1, 2, 3, 4, 5. You got 5 questions to answer. And that is the density lab that you've got for this week to do. I just need to go ahead and video and buy the materials for the other pancake syrup and the rubbing alcohol. And I will show you that video, or I will put that up probably by Monday night. I'm going to try my best to get that done. All right, Tuesday we are going to have a meeting since school is on Tuesday. There is no school on Monday. I'm going to go back and double check the calendar over here. So we're on week 3, video notes. Hopefully you have those done. The unit notes, hopefully now you have those done. Homework number 1, has already been on there since last week. CK12 website has already been on there. Hopefully you are started that at least. And then we have now our lab. Okay, so those are the things that need to go on there. We are going to cover a few things when we see each other on Tuesday. One thing that we are going to go over is we're going to go over the test together. I have all those questions ready to go over with you. I will go over homework 1, a few problems with you, make sure everybody's on the same page. I'm going to ask you if there's any questions on the notes, because that's one section or 2 sections regarding the practice problems that we're going to do together in class on our teams class. And then we're going to go over what we call the diatomics. Okay, I'm going to have a periodic table, and hopefully you printed out your formula chart. It is on your chemistry work folder under Blackboard. Okay, but I will go ahead and pull out a periodic table, and I'll show you the 777 rule. And I'm telling you, I've got students who are taking other chemistry classes with other professors, and they just tell them to memorize it. But I'm telling you though, if you use my little hints, it's going to be so much more easier. We use diatomics all school year long, so we need to know what they are now. And that's about it. So we'll see each other on Tuesday. Let me post this right now so you can have this video, and hopefully you're printing this out. All right, you have a good night. Bye-bye.